So, to factor or to complete the square. Let's consider a slightly different problem. First thing we would do is collect all of our terms on one side, try to factor, find out where those values are 0, and then check to see if this expression is bigger than 0, positive, or less than 0, negative, based on these values. So we check for values less than -5, for values between -5 and -2, and for values above -2. Well, if a value was less than -5, say like -10, this expression would be a negative times a negative, which would be a positive. And if our e value is between -5 and -2, say like -3, then we'd have a negative value times a positive value, which would make this product negative. And then finally, if our e value was greater than -2, for example, like e equals 0, then this product, our expression, would be positive times positive, which would be positive. So for this equation, the solutions would be whenever this was true is equivalent to whenever this is true, and this is bigger than or equal to 0 when it's positive, which is when e values are less than -5 or greater than -2. So when you can factor this expression, this is how you can figure out the solutions. Well, for this problem, when we collect all of our terms on one side and 0 on the other, if we try to factor it, we see very quickly that it's not factorable. You cannot factor this quadratic trinomial. So we're going to have to try something else. There is more than one way to do this, but this solution will use the idea of completing the square. I'm assuming that you know how to complete the square, so I won't talk at length about it, but if you have any questions, let me know. So half of 4 is 2, and 2 squared is 4. So we'll add 4 and subtract 4. So now 0 is less than or equal to, and this simplifies to n plus 2 squared, and 10 plus 4 is 6. Alright, now let's subtract 6 from both sides, and we get -6 is less than or equal to the quantity of n plus 2 squared. So recall, we're trying to solve this inequality. It's equivalent to solving the inequality at any step of the way because they're all equivalent. So solving this inequality is equivalent to solving this inequality. And this is asking, when is something squared bigger than or equal to a -6? Well, if you're squaring something, it can't be negative. It's going to have to be at least 0 or some positive value above 0. So it doesn't matter what n is. Positive or negative makes no difference. When you add it to 2, the square of this quantity will always be at least 0 or bigger. And that's always bigger than -6. So our solution is that n can be any real number.